Hello friends, let us resume our discussion on mineral processing as a whole. So we have been so far considering the basics of the mineral processing. Particularly we have categorized the whole mineral processing into two different techniques. So one is referred to as the liberation, while the other is referred to as the concentration. So whatever we have seen in the liberation is just an overview of what that particular technique involves. We will be considering the nuts and bolts of this technique in the subsequent modules. Particularly, if you could recollect, we have a separate module on comminution, and we will be considering largely, or we will be trying to comprehensively understand the different aspects that are involved in the comminution process, that is a part of the liberation technique. Now, we saw in the previous lecture that the process of liberation, it involves a particular process chain. It follows a particular flow chart. So this flow chart, it begins with a feed. This feed is nothing but the mined out large sized particles. So this feed is allowed or is fragmented into smaller pieces. So what we introduce is we impose this feed to comminution, or we impose comminution on this feed, meaning we fragment the larger mined particles into smaller pieces. And this process of comminution, it yields us three different types of smaller particles, which we refer to as minerals, then middlings and tailings. Now we separate out the minerals and use it for subsequent different processes, and tailing is discarded, and it's the middling that is sent back or fed along with the other feeds for further comminution. So this approach is purely theoretical. This approach assumes that whenever we introduce the feed, there is an equal proportion of minerals, middlings and tailings being produced. So this flow chart is it follows, or it is because of a specific assumption, that is you have your mineral that is encapsulated by a gangue, and this mineral is present in a specific location and it is localized. So it means when you fragment this particular large particle, then there is an equal amount of minerals, middlings and tailings. So there is an equal proportion of free mineral particle, free gangue particles and middlings. So when you have such equal proportion, then it is possible for us to separate these middlings and tailings and feed the minerals and tailings, and feed just the minerals middlings into the subsequent comminution. However, we saw in practical cases this is not be followed, because in practical instances the assumption that undergirds this particular process chain, it is relaxed or it is compromised, meaning unlike the theoretical consideration of a mineral occupying a localized position in a larger particle surrounded by the gangue mineral, in actual physical case what happens is that we have mineral that is being spread all through the larger particles, and they assume a hill defined shape, and also they are intertwined, they are found in the forms of smaller pockets. So this means that we again begin with the feed, and we again introduce this comminution here. However, even though we are able to identify certain free particles, that is free mineral particles, and free tailings, that is free gangue particles, these amount of these are quite low. So the proportion of the mineral particles and the tailings are quite low. There is a significant amount of, or the predominantly the particles are made up of what we refer to as middlings. Now it is not economically beneficial if we introduce or if we impose the second degree comminution on all of this middling. So we consider, or we arrive at an acceptable degree of minerals or acceptable degree of gangue. This helps us just separate the middlings into the mineral particle, free mineral particle and free tailing particle. So we agree upon a specific acceptable level of minerals and gangues that is present within in the middling particles, And once this acceptable level of minerals and gangue is set, we can categorize, just by considering the middlings alone, we can categorize certain middlings as free particles, even though they are not exclusively comprised of the minerals alone, because they comprise of greater than or equal amount of the acceptable level of minerals. We can categorize that portion of the middlings as free mineral particles. And similarly, since they contain the greater or equal amount of the gangue mineral, we can categorize a specific portion of the middlings into tailings, and we can subsequently treat these acceptable portion of acceptable level of minerals and acceptable level of gangue as we would treat the minerals and tailings respectively. Now the rest of the middlings we can send it back, or we can subject it to the second degree comminution. So it is not these two, since these two are rather found in smaller quantities, these middlings are then using this acceptable level of minerals and acceptable level of gangue. These are subsequently, they are distinguished into mineral particles, tailings, and then middlings. So these are second degree middlings, or these are first degree middlings, and it is the second degree middling that is being sent back into the feed. So this is the difference between rather a theoretical consideration and a physical observation. So this is a physical observation and this is the theoretical consideration. So it all depends on the nature of the particles that we consider as the feed. It is also possible that in some instances, in some reserves, the particle that you get is close to the theoretical particle you have considered. So in those cases, the process chain would vary, or it will follow the first process chain. However, in most cases we have to follow the second process chain, because it is often these minerals are distributed quite randomly and they assume quite random shape, and therefore we need to further process the middlings to distinguish them into mineral particles, tailings, and the second degree middlings, and it is the second degree middlings that is considered as the feed for the subsequent comminution. So this is again economically beneficial to us. Now we saw in the previous lecture that even though this two different process chain, it seems to have captured the overall techniques or overall processes that is involved in the liberation, we have not considered one critical aspect. There is one critical aspect in addition to comminution that is being involved inherently in this process chain. So far we have assumed, or we have taken it for granted, that once you have the particles, it is rather straightforward to separate them into minerals, middlings, and tailings. So this process of separating minerals, middlings, and tailing, we have just taken it for granted. However, this separation of a given mixture of smaller size fragments into mineral, middlings, and tailings is rather a specific process, and it follows a specific or a particular approach, and this is what we refer to as the concentration. So concentration is essentially a part of this flow chain, or is part of this process chain, which we have so far have taken for granted. We have just assumed that it is easily possible, or it I don't know, maybe when the outcomes of comminution is rendered, it appears in the form of these different categories of particles. So we have assumed that. However, it is not the case. We have to have specific processes to separate minerals, middlings, and tailings. However, even though it is the concentration technique that separates these two, if you consider the technical description of concentration, the technical description of concentration is the process that separates minerals from the rest of the particles. So the concentration, even though this approach can be adopted to separate a given mixture of particles into minerals, middlings, and tailings, the technical definition is the separation of minerals alone from the rest of the particles. So what essentially concentration means is that, or what essentially concentration considers, is that it just considers two categories of particles. One is minerals, the other is middlings and tailings. So that is how the concentration is technically described or technically defined. However, since the approach that is taken, the overall approach that is taken, can also be slightly modified into separating the rest of the particles that are not minerals into middlings and tailings, the concentration is involved inherently in this process chain to give us 3 different types of particles. So let me repeat. Technically, from a purely technical perspective, concentration is a process that categorizes or that considers the whole of the fragments and separates the whole of the fragments into minerals or the mineral rich fragments and the rest. So this is all the technical definition of concentration involves. However, given the approach that is adopted for concentration can be refined in such a way that the rest can be even subdivided or even they can be categorized into middlings and tailings. This process of separating the overall mixture of the fragments into minerals, middlings and tailing is referred to as the concentration. So there is a difference in the technical description of concentration and how it is being practically used in the overall process chain of the liberation. Now, if you consider or if you include this concentration in the process chain, then the overall flowchart that we have considered will undergo subsequent changes. So when you consider the concentration as a separate process, so far we have taken the separation of the mixture of the particles into minerals, middlings and tailings as we have assumed it to be inherent. Now if you introduce concentration as a separate technique as that of liberation, then the overall process chain would look something like this. So we will again begin with the feed, then you introduce comminution, and this comminution, it gives us mixture of particles or mixture of fragments, and now this mixture of fragments need to be subjected to concentration. And if you consider just the technical description of the concentration, it will give you minerals and the rests. However, since again the approach is the same, we can play around with it and we can tweak the concentration to give us tailings and middlings. Since the primary outcome of the process of concentration is the mineral, the intended outcome of the concentration process is the minerals or the mineral rich fragments, we refer to this mineral or the mineral rich fragments as concentrates. So ideally, like the gangue rich particle or the gangue fragments and the particle, the locked particle that comprises of gangue and mineral, they have their characteristic terminologies. Since concentration is used to realize or to describe or to separate the minerals, these are referred to as concentrates. So essentially, what comminution gives you is a mixture of particles that comprises of concentrates, middlings and tailings. Now, when you consider the practical condition, then it means the amount of mineral and the amount of tailings, they will be considerably low. So therefore, what needs to be done is we need to further work on this middling here, and we have to further impose the middling to concentration. Now under the new condition involving accepted level of minerals or accepted level of gangue. Now this further treatment of middling to allow it to be categorized as free particles then again involves concentration, but now the criteria for concentration has changed. Instead of considering purely or exclusively mineral particle or exclusively gangue particle, now the criteria for concentration involves acceptable level of minerals and acceptable level of gangue particles, and therefore this second degree concentration gives us concentrate, again a middling and tailings. So similar to the comminution, we have separate degree of concentration. So the initial concentration here, it considers the criteria for concentration in this case is a particle should be completely made up of a given mineral. It can be the valuable mineral or it can be gangue, only then it will be treated as the free particles. Only then it will be treated as a concentrate or tailing respectively. In the second degree of concentration here, so this let us assume it to be first degree, and in the second degree concentration here, since the proportion of such free particles is quite low, we have to, for our economic benefits, we have to consider some of these middlings to be, some portion of these middlings to be free particles, and therefore our criteria for concentration, particularly second degree concentration, it changes, and this criteria is based on acceptable degree of minerals or acceptable degree of gangue, and based on this criteria you are then referring to a specific portion, a specific kind of the locked particles as the free particles, and we are referring to them as concentrate and tailings depending on the portion of the minerals or gangue that is present in these particles. And now it is the middlings that are subjected to the second degree comminution. So second degree comminution. So this is how the overall process chain looks like when we want to process the particle that has been fed to us. So we have a mined out particles and we want to get just the fragments of our valuable mineral, and the starting point is a large particle wherein the mineral is being encapsulated by a gangue mineral, and this encapsulation is not regular. We have this mineral or the valuable mineral being distributed rather randomly within this large particle. So in that case, the overall process chain that we need to follow will be of this form. So it is the combination of liberation and concentration that gives us at the end a fragments that is largely comprising of the minerals. So the flow chart, it is not exclusively made of liberation, or it does not exclusively considers liberation. This flow chart, it combines both liberation and concentration. Liberation particularly in the form of comminution, and concentration. So this is how the process chain, where the starting point is the large size feed and the ending point is the fragments of our desired mineral, looks like. We have two in this smaller, in this rather schematic process chain, we have considered two different degrees of comminution and two different degrees of concentration. So this is, I believe, a sufficient introduction for the concentration. Again, the technical description of concentration is that it is a process that separates the mineral rich fragments from the mixture of the fragments. So it just separates the mineral rich fragments from the rest. It does not worry about middlings or tailings, it just is focused on the minerals alone. Now since the approach is the same, we adapted to separate the rest into tailings and middlings, and we do it for our sake. So this is how the overall process chain that starts with feed and that starts with larger mined out particles and that ends with smaller fragments of our desired minerals look like, and it is again the combination of liberation and also concentration. Now again, similar to liberation, since we saw just, or we considered just an overview of the process of liberation, we will be also considering the overview of the process of concentration, the different techniques that are involved in the concentration. We will be spending considerable of quite some time in understanding each of these concentration processes. However, in this case, since we are considering the overall basics of the mineral processing, we will invest some time to understand the different techniques that are involved in the concentration. So this is not all we will be studying in this course. We will be investing some more time on each of these techniques, but let us consider just an overview of different techniques that are involved in the process of concentration. So we have seen that the definition of the concentration, it is largely focused on the desired mineral. So if you consider the technical definition of the concentration, its role is to give us concentrate, which is nothing but the mineral rich particles. So therefore, of course, in the practical instances, we will be using this process of concentration for different separations as well. Since now we are considering, or we are attempting to discuss the theoretical aspects of considerations, or rather concentrations. Now let us focus or confine or restrict ourselves to the technical description of concentration. So again, even though this concentration can be used to separate the rest into middlings and tailings, for our discussion, for this discussion, let us restrict ourselves to the technical description of concentration, which is to separate the valuable mineral from the rest of the mixture. So when you have in your feed a large size mined particle into the comminution, what you end up getting is mixture of different particles. And this from this different particles, we need to separate the mineral particle that is of value to us. So in order to do that, what we exploit is, or what we make use of, is the properties of the minerals. If you could recollect, we spent some time understanding the different properties of minerals and where they stem from. And we use these properties of minerals for separating the mineral rich particle or the concentrate from the rest of the mixture. So the first property that we will be considering is the optical property, or the way a mineral appears. So depending on the chemical composition of a mineral, the color the color in which a mineral appears might change, and the way a mineral appears might also change. The morphology of a mineral might also change. So depending on the appearance alone, we will be able to differentiate a particle, if a particle comprises of a specific mineral or not. Supposing if a mineral exhibits, or if it appears in the form of green color, and its gangue appears in the form of, say, like any other rock, in the form of say a gray color, then in that case, just by appearance alone, depending on how much green shade is there in a given fragment, we will be approximately able to state how much mineral is associated with that particle. So essentially, this is referred to as sorting. So sorting is a technique that is involved in concentration. This process of sorting, it makes use of the optical, or rather the physical appearance of a given particle, a given concentrate particle. Now this appearance is largely based on the color of this mineral. So if your particle is close to that of the color of the desired mineral, it means that this particular particle is rich in that mineral. So again, to give you an example, if a mineral appears in its pure form, or in its purest form in green color, then if your particles if your particle that comprises of, or it predominantly is in green color, then it means this particle is predominantly comprises of this mineral, and therefore it can be treated as the mineral rich particle. And this approach is referred to as sorting, and it is similar to that of our hand picking. So essentially, the process of sorting, which is a technique that is involved in concentration, it just considers the physical appearance of the particles, and the property that is involved is the appearance of the particle, and the appearance of the mineral rather. And if you could recollect, the appearance of the mineral is dependent on the chemical composition of the mineral. We saw an example where just by changing the chemical composition, we were able to arrive at two different minerals which had two different shades associated with them. So when you have a mineral that is associated with a specific color, and when you compare that color to a given particle, depending on how much amount of the color you are able to see in this particle, you will be able to estimate amount or the fraction of mineral present in this particle. And this is by assessing how much of the amount of mineral present in this particle, we will be able to treat this as mineral rich particle or mineral deficient particle. So sorting is one of the techniques that is associated with the concentration. The other technique involves gravity separation or gravity concentration. So what gravity concentration, the overall process of gravity concentration involves is that these mixture of fragments that comprises of concentrates, middlings and tailings, these this mixture of fragments, they are suspended in a given fluid or a given medium, and they are allowed to move. And depending on the movement of these individual particles, they are separated into concentrates and the rest. So again, what essentially is being done is a definite movement or a definite degree of motion is introduced into these different particles, these mixture of particles, and depending on the movements exhibited by these category of particles, the concentrate is separated from the rest. So the properties that governs the movement of the individual particle is the density. So when you have a high dense mineral and when you see that a certain category of fragments, they are not that much mobile, then you can say that the high dense mineral is predominantly present in these particles. And if you see quite the rest of the particles that easily move in a given medium, then you can say the amount of this high dense mineral in these particular category of particles that easily move is not that much. So what essentially gravity concentration does is it exploits the density of a given mineral. So depending on the density of a given mineral, the movement of the particles vary. When you have a predominantly rather dense particle that comprises of the mineral, then its movements will be restricted, and therefore we can say that this category of particles, they are rich in the desired minerals. And depending on how immobile your particle is, you can state the amount of, you can predict the amount of minerals that is associated with this particle. So you have highly mobile particle at one end of the spectrum, and you have the least mobile particle or immobile particles at one end of the spectrum, and the one end of the spectrum which is least mobile, it refers to the highly dense valued mineral, and the other end of the spectrum, it refers to rather the gangue minerals, that is which can be referred or which can be treated as the tailings. So this approach, this process or this technique of gravity concentration, it uses the difference in the density between the minerals and the gangue particles. So only when there is a significant difference in the minerals density of the minerals and the gangue particles, this particular gravity separation or gravity concentration technique can be used. Now, in most cases, the medium in which these particles are suspended in case of gravity concentration is water. However, when the difference in the density between the minerals and the gangue, if it is not so much, when it is not so significant, then a dense medium, a medium that is quite dense when compared to water is used, and in that case the similar approach, the similar technique of concentration is referred to as dense medium concentration. So the specific aspects of these techniques, particularly the technique wherein the density is employed, depends on the difference in the density between gangue and the desired concentrate. So when the gangue and the desired concentrate, they exhibit a significant difference in the density, it can be that the concentrate has low density and the gangue has higher density, or it can be that the gangue has lower density and the concentrate has higher density. Irrespective of it, when the difference is quite large, then we go for gravity concentration using water. When this difference is not that much large, then we use dense medium, but both these gravity concentration and dense medium concentration, it is dependent on the difference in the density between the concentrate and the gangue particles. And depending on the difference or depending on the density of the concentrate and the gangue, the spectrum varies, and depending on how mobile your particle is, you will be able to identify mid-lengths as well. Now, the other technique that is involved, again, these are just the overview of the different techniques. We will be spending some amount of time in order to understand the specific of these different techniques. So this is here we are considering just the overview. We are just introducing ourselves or exposing ourselves to different techniques that is involved in the concentration. We will be spending some more time in understanding the basic or the fundamental aspects of each of these techniques individually. So the other technique, which again we will be spending some amount of time on, is the froth flotation. So what the froth flotation process or this particular technique involves is that it involves it exploits the chemical composition of the given mixture of particles, and it rather manipulates the surface property of the particles. So essentially our fundamental description or the distinguishing feature or one particular or important distinguishing feature of a mineral is that the minerals are associated or they are a specific or definite chemical composition. So even though gangue is a form of a mineral and we have our valuable mineral, the concentrate is again a mineral. So even though these both are categorized or these both can be categorized as mineral, the one distinguishing feature is the chemical composition. And based on the chemical composition, the response they would render to a chemical reagent, it varies. So we make use of this varied response of the concentrate and the gang to a chemical reagent. We make use of this response and we attempt to separate them in this technique of froth flotation. So essentially this is again based on the chemical composition of a given mineral. So the reason we are able to use froth flotation as a technique to separate gangue from the concentrate is because of this varied chemical composition and the way they would interact with a chemical reagent. Now what essentially happens in this froth flotation process is that we expose this mixture of minerals or the mixture of this different particles to a chemical reagent. This chemical reagent, instead of reacting all through, or instead of changing the chemical composition of the minerals and the gangue, which will spoil the whole processing, what essentially this chemical reagent does is it manipulates the surface. So this is something we need to understand, that this chemical reagent, it will not react with the mineral or the gangue and it would change the overall composition of the mineral and the gangue into something else, because if it does so, then the whole process, the whole technique that we are using will be in vain, because ultimately the very mineral has lost its chemical composition. So even though the froth flotation involves a chemical reagent, even though it involves a chemical reaction, it is largely confined to the surface, and even that is not a change in the chemical composition, or even the manipulation of the surface, it's not a change in the chemical composition, but it changes the way a particle would behave in water. So essentially what the froth flotation does is, or the chemical reagent that is employed in the froth flotation does is, it interacts with the different particles and it categorizes, or depending on the chemical composition of the particle, the interaction would vary, and some interaction would give a specific some interaction would give a specific way in which the particle would relate to water. So what I mean by that is, this chemical reagent that we use, it interacts with the mineral in such a way that it makes it hydrophobic, meaning it makes it water repellent. So it will not change the chemical composition of the mineral, but it will create a surface. It will make the surface of the mineral in such a way that it is water repellent. So the interaction between the chemical reagent and the different particles will not change the chemical composition of the particles, but rather it manipulates the surface in such a way that these particles, either they are attracted towards water or they are repelled by water. So this is what happens in the first step that has happened in the froth flotation, is that it transforms the particles into hydrophobic, that is water repellent, or hydrophilic, which is it is being attracted by the water. So again, even though we involve a chemical reagent in this froth flotation, this is not to introduce a chemical reaction, because a chemical reaction will change our desired chemical composition of the concentrate, which is not very much appreciated. We don't want to change the chemical composition of the naturally available mineral. That is not at all what we want to do. But instead, what this chemical reagent does is manipulates the surface of each of these particles in such a way that the interaction between the particle and the water is different. So certain particles, they are attracted towards the water, and certain particles, they are attracted or they are repelled by water. So this chemical reagent is chosen in such a way that either the concentrate is attracted towards the water or repelled by the water, whereas the gangue is attracted towards water or repelled by the water. So that is how the chemical reagent is chosen in order to make the distinction between the concentrate and the gangue, and the distinction is made by the way it interacts with the water, and this is achieved by the chemical reagent. Again, the chemical reagent only manipulates the surface. Now once we have achieved a degree of the hydrophobic or hydrophilic interaction of these particles with the water, then the froth air bubbles are introduced in this mixture of the chemical reagent and the mixture of the different particles. So essentially the froth flotation involves allowing the chemical reagent to mix up with the mixture of, or to allow the chemical reagent to form a sludge with this mixture of these different particles. And this sludge, because of the interaction between the chemical reagent and the particle, it forms a surface that is either hydrophobic or hydrophilic. And this surface, this manipulation is dependent on the chemical concentration of the mineral and the gangue. So for a given specific chemical composition of the mineral, it will form either hydrophobic surface or a hydrophilic surface, and a different composition of the gangue, it will form either hydrophobic surface and hydrophilic surface. So ultimately, if the concentrate is hydrophobic, your gangue will be hydrophilic. If your concentrate is hydrophilic, your gangue will be hydrophobic. So such a distinction is made on the surface of the particle, and once this distinction is made through the chemical reagent, then air bubbles are introduced into this mixture of these different particles and the chemical reagent. And when the air bubbles are introduced, these hydrophobic particles, which are already repellent to water, they get attached to the air bubbles and they reach the surface of the sludge, while the hydrophilic, they do not get themselves attached to the air bubbles, and because of their density they settle down at the bottom of the sludge. So this is how the separation is achieved in, or the concentration is achieved in the froth flotation. So what froth flotation does is, it employs or it makes use of the difference in the chemical composition between the concentrate and the rest of the particles. Now, since the concentrate, the mineral that is of desire to us, the valuable mineral, it has a specific composition. A specific chemical reagent is chosen in order to manipulate its surface and make it either hydrophobic or hydrophilic. And once the surface of our desired particle is made hydrophobic, then the surface of the rest of the particle is made hydrophilic through the same chemical reagent. Once a distinction is made between these different particles by the way they interact with the water, by the way they are attracted or repelled by the water, then the air bubble is introduced, and the hydrophilic particles, they will not interact with the air bubble, and since they are attracted towards with the water that is already present in the sludge, they settle down, whereas the hydrophobic particles, they get attached themselves to the air bubbles and they are transported to the surface of the overall sludge, and thereby allowing us to separate them out. So this is how the process of froth flotation works, and again this is a chemically specific process that is dependent on the difference in the chemical composition of the gangue and the mineral or the concentrate particles. So far we have seen three different techniques that are largely used or that can be used for the process of concentration. So one is sorting, that exploits or that uses the difference in the physical appearance of the mineral and the gangue particles. And again, if you consider the fundamental property of the mineral that governs the physical appearance, it is again the chemical composition. So indirectly it is the chemical composition that dictates the process of sorting through the physical appearance. And the second technique that is involved in the process of concentration, which we have seen, is the it involves gravity, concentration, or dense medium concentration. This technique of concentration, it is governed by the difference in the density of between the concentrate and the rest of the particles. So depending on the amount of minerals present in a given particle, the density of that particle varies, and this particular technique uses that difference in density in order to concentrate or in order to separate the desired mineral particles from the rest of the particles. And thirdly, we saw there is froth flotation, which explicitly uses the difference in the chemical composition thereby manipulating the surface of the particles. So it uses the chemical composition to manipulate the surface of the particles. So depending on the chemical composition, either the particle will be hydrophobic or hydrophilic. Once this distinction is reached, then by introducing air bubbles, we are able to separate the desired mineral particles from the rest. One other technique that is used in the process of concentration is magnetic separation. So as the name indicates, this particular technique, it exploits or it uses the difference in the magnetic behavior of the minerals and the rest of the particles, magnetic behavior of the minerals and the rest of the particles, to differentiate or to separate the concentrate from the rest. So the mineral can be highly magnetic particle, or it can be or the gang can be highly magnetic particle. So because of this difference between the magnetic behavior, the magnetic separation is employed. Because of this difference in the magnetic response of the mineral and the rest, or the concentrate and the rest, the magnetic separation is used to separate the concentrate from the tailings and middlings. So all the process of the technique of minerals the magnetic separation is primarily due to, or it is can be used wherein the magnetic behavior of the desired mineral is different from that of the rest of the gang particles. Now, depending on how the magnetic behavior is, or how the response or the magnetic response is to a given magnetic environment, different separators are being used. So one can use a low magnetic separator when the desired mineral is highly or responsive to a magnetic condition. So you expose your mixture of particles to or you expose your mixture of particles to a magnetic environment, and if your desired mineral, if the concentrate that we are interested in is highly magnetic, then its reaction will be active, and therefore you do not need high degree magnetic separators, but low degree magnetic or low magnetic separators will do the job for you. And therefore, depending on the level or the degree of response or concentrate gives to a given magnetic environment, the approach that we take also vary. When the desired mineral is highly magnetic, or it can also be that the desired gang is, or rather the undesired gang rather, is highly magnetic, then all we need to do is expose this mixture of particles to a low magnetic separators, meaning the magnetic field that we expose this mixture of particles can be low, because since that the concentrate or the gang is highly responsive, despite the low magnetic field in which it is being exposed to, the response will be sufficiently active for the separation. If the concentrate or the gang, if it is not highly magnetic, then we need high magnetic separators. So in order to introduce, or in order to allow the gang and the desired mineral or the concentrate behave separately, we need to choose the separators appropriately. If our concentrate is highly magnetic, or if our gang is highly magnetic, then a low magnetic field is sufficient. The sufficient amount of movement can be produced by this low magnetic field that allows for our concentration. However, on the other hand, when the concentrate or the gang is not sufficiently magnetic enough, then we need to impose a high magnetic field through the high magnetic separator. Only then we will be able to establish the required amount of movement for the separation of the magnetic separation of the concentrate from the gang. So the magnetic separation, as the name indicates, it depends on the difference in the magnetic behavior of the gang and the mineral. So it can be that the gang is highly magnetic, or it can also be that the mineral is highly magnetic. So depending on the degree of the magnetic response that each of these particles render, we can either choose a low magnetic separator or high magnetic separator. The reason this low and high magnetic separator, the distinction is made, is because again the amount of monetary expenses that is being fed into these separators are quite huge. So therefore, when you have an highly responsive gangue or mineral, and if you subject them to high magnetic separator, then it is just a waste of our monetary expenses. So in order to be optimal, we have to first understand the degree of responses these particles they give. So the degree of response to a given magnetic field these particles give. So only after understanding the degree of responses and how these particles respond. So either the gangue can be magnetic or the mineral can be magnetic. So this distinction first we need to take, and we need to estimate that, and we need to understand that. And once we are sure about what is the magnetic response that is rendered by the gangue and the mineral, then we have to understand what is the degree of response, if the gangue is, or if the particle is highly magnetic, or if it is not that much magnetic. Once this distinction is made, we have to choose our separators. So the magnetic separation, we need to first realize which particle behaves in which manner, if the gangue is magnetic or the mineral is magnetic. In either case, we will be able to use this magnetic separation. If there is a difference in the magnetic behavior, we will be able to use this magnetic separation. Now once identifying that a given particle behaves in a specific way, we need to identify what is the degree of the response, and depending on the degree of response, you will be able to choose either high magnetic separators or low magnetic separator, which will help us make the optimal use of our monetary resources. Now the final technique, or in case of these wide categories of the different techniques that are involved in concentration, this final technique is referred to as the electrostatic separation. So the electrostatic separation, it makes use of the difference in the conductivity, the electrical conductivity of the gangue and the mineral particle. So you have concentrate and gangue, and also some middlings that are mixed up in the form, or they are mixed up as when we get it from the way it is being given to us is a mixture of these different particles. Now these different particles, when they exhibit a different degree of conductivity, then electrostatic separation can be exploited in order to separate the concentrate from the rest of the particles. Now again, when what the process of comminution renders us is the mixture of the different particles, and these different particles, they have varying proportion of our concentrate and also the gangue mineral. And because the mineral or the desired mineral exhibits a different level of conductivity, particularly the electrical conductivity when compared to the gangue, we will be able to distinguish the concentrate from the rest by understanding how much a given particle conducts electricity, how much electrically conductive a given particle is. So depending on the amount of the desired mineral that is present. So supposing we assume a case wherein the desired mineral is highly conductive. So depending on the amount of this particular mineral that is present in the particle, the conductivity would vary. When a particle is highly conductive, it means that particle predominantly comprises of our desired mineral, and as the conductivity of the particle decreases, it means the amount of this desired mineral is also decreasing. So the difference in the conductivity between the different minerals, the gangue and the desired mineral, is exploited in case of electrostatic separation. Since in most of the cases there is a significant difference in the electrical conductivity, this electrostatic separation is often universally employed. So of all these techniques, since in large instances, or in almost a significant proportion of the instances, the conductivity of the gangue and the desired mineral is significant, or it's considerably different, then in such instances, so since it is widely observed, this electrostatic separation is often considered as a universal technique for the concentration. Now again, the reason for this universal consideration is because of the difference in the conductivity between the desired mineral and the gang, and which again depends on the chemical composition. Again, we can trace most of these properties to chemical composition, more so with the conductivity, or particularly the way these entities are being bonded, if you could recollect our previous discussion. Now essentially the electrical conductivity, the difference in the electrical conductivity is being used in the electrostatic separation for distinguishing the concentrate from the rest. And finally, even though this is universal, but since electricity is being involved in the process, the safety measures need to be taken while employing this technique. So we have to be extra careful while employing this particular technique. So with this overview of different techniques that are involved in the concentration, I would like to wind this lecture up. And in the next lecture, we will be considering few general aspects of the processing of concentration, and then we will be moving on to the next module on combination. So we'll see ourselves in the next lecture. Goodbye.